Hello everyone, welcome to the video on frequency of oscillations of RC phase shift oscillator. In the previous video I explained the introduction part of the RC phase shift oscillator. In that I discussed how RC network gives a phase. Okay, so this is the RC phase shift oscillator using BJT. It consists of the CE amplifier and this is the feedback network. Okay. And now I'll derive the frequency of oscillations. Previous class I mentioned one point, this R3 comes with the series with HIE of the transistor when we are analyzing using H parameter model. Okay, so this is base, emitter and collector. So now R3 gets added to HIE, so R3 plus HIE, which is actually in parallel with R1 and R2. R1 and R2 values are very high compared to R3 plus HIE. So the result is R3 plus HIE. So you can take it as R. So totally there are three similar RC networks which will produce totally 180 degrees phase. Each RC network produce 60 degrees phase. Okay. So now to obtain the frequency of oscillations, I am just replacing this circuit with H parameter model. I am just drawing the H parameter model. Base, collector and this is emitter. Between base and emitter we have HIE. Between collector and emitter we have HFE-IB. Yes, at this collector you have to add first RC because while doing AC analysis you have to make VCC is equal to 0. When we made VCC is equal to 0, RC gets grounded and now you can connect that ground to this ground. So from the collector, yes, emitter is grounded and then yes, after this the capacitor C, then this resistor R, again the capacitor C, this resistor R, again the third capacitor C, yes, actual resistance is R3, then this R3 gets connected to the base. Yes, now if we see R3 and HIE are in series. That is the reason I told that R3 plus HIE, which is nothing but R. Now when you add HIE to the R3, HIE other end is grounded, all this is grounded. So instead of going like this and making ground here, I am grounding here. So the circuit is third C and then here R, that is R3 plus HIE. Yes, all these are grounded. So this is the emitter part and the current source is HFE-IB. Now we'll change this current source to the voltage source. Here there is a current source in parallel with the resistor RC. Now after source transformation, the circuit becomes so next is C, then the resistor R, again C, R, C, R. Okay. So actually it is plus minus HFE-IB RC. Just multiply this current with the resistance HFE-IB RC. But remember this CA amplifier is a 180 degrees phase shift provider. So that is the reason you have to take these terminals as this is minus and plus. So now assume three currents, I1, I2, I3. At this point I want to explain about the feedback factor. Yes, what is the input current for amplifier? What is the input current? This is IB. Okay. What is the output current for amplifier? What is the output current? Yes, it is IC. And all of this is the feedback network. So what is the input current for feedback network? Output current of amplifier is nothing but input current of the feedback network. Okay. So this is the feedback network. You are giving input like this. So the input current for feedback network is IC. What is the output current for feedback network? See this, we assumed three currents. Here is I1, here is I1, here is I2, here is I3. Okay. So what is the output current? I3. Okay. So what is beta now? Feedback factor beta. Output of beta network divided by input of beta network, means input current and output current, like that you have to take. So what is the output current of beta network? I3. What is the input current of beta network? IC. Okay. I3 by, what is IC? HFE IB. Then what is the gain of the amplifier A? Same. Output of amplifier, means output current of amplifier, divided by input current of amplifier. So what is output current of the amplifier? IC. Input current of the amplifier is IB. You know IC is HFE IB divided by IB. So you will get HFE. So now the loop gain A beta is equal to HFE into I3 by HFE IB. So it is I3 by IB. So the loop gain A beta plays the main role. It decides the condition for oscillations. So finding A beta is enough to find the frequency of oscillations. But to find A beta we need I3 and IB. IB is the circuit current, no problem. But I3 you have to find by using this circuit. Okay. So now how to find I3? Now I am going for the Cramer's rule. So for that, first you have to write the loop equations for this circuit. Yes. So now I am writing the equation, KVL equation for this loop. Now the current flowing through these three components, RC plus R minus JXC of I1. Okay, then to this R, I2 is coming. So it is RI2, but in I1 is this direction, I2 is in this direction. So both are in opposite direction. So it is minus RI2. And if you see, it becomes, there is a voltage source. It is HFE IB RC is equal to 0. Okay, now just I am modifying it. RC plus R minus JXC of I1 minus RI2 is equal to minus HFE IB RC. Let be equation number 1. Now the second loop equation, here totally again 3 components. So the second equation is 2R is 2R minus JXC, because the capacitance reactance is JHC. Yes, it is its current I2, but through this R I1 is also going, and through this R I3 is also going. So totally you have to write minus RI1, because I1 and I3 are in opposite direction to the I2. So it is minus RI1. Another one is minus RI3 is equal to 0. Okay, again I am rewriting it. Minus RI1, okay, plus 2R minus JXC of I2 minus Ri3 is equal to 0. Let it be equation number 2. Okay. Next, the third equation. So again, same 2R's. 2R minus JXC of I3. Okay. So here only there is a provision for I2 current. So that is minus Ri2 is equal to 0. So again I am rewriting it. In this equation there is no I1. So it starts with only I2 minus Ri2 plus 2R minus JXC of I3 is equal to 0. So let it be equation number 3. See that JXC is J by omega C. Okay. Yes, you can write it as J by J. Just you multiply with J and divide with J. So J square becomes minus 1. So it becomes minus 1 by J omega C. Yes, now take this J omega as S. Replace J omega with S. So it is totally minus 1 by SC. Okay, so replace JXC with minus 1 by SC. Now, if you rewrite the three equations, okay, let us see the first equation. The first equation becomes, here you have to take another thing also, RC is equal to KR. Okay, so now if you keep RC is equal to KR here, so you can take R common, so it gives R of K plus 1. Okay, so the first equation is K plus 1 into R. Yes, in the place of JXC, substitute minus 1 by SC. So it is minus JXC. So it becomes plus 1 by SC into I1 minus Ri2 is equal to minus HFE IBRC. Let be equation number 4. Equation number 2 implies minus Ri1 plus 2R plus 1 by SC into I2 minus Ri3 is equal to 0. So this is equation number 5. Then equation number 3, minus Ri2 plus 2R plus 1 by SC into I3 is equal to 0, equation number 6. So now take delta. This is all by using Cramer's rule. Then I am going for the det. This is the det. First write this I1 coefficient. Then I2, that is minus R. Here in the fourth equation there is no I3 term, so keep it 0. Then second one, equation number 5, that is minus R, 2R plus 1 by SC, and then minus R. Then here it is 0 because there is no I1. Then minus R, again 2R plus 1 by SC. So now you have to find the det value. As you know how to find the det value, first is K plus 1 into R plus 1 by SC. This term, you have to leave this column and this row, then multiply this AD minus BC. Yes, this into, yes, 2R plus 1 by SC whole square minus of minus R into minus R, that is minus R square. Okay, then minus of this second term, that is plus R of, is you have to leave this and this. So now multiply this with this minus this with this. So this term becomes 0. So just you have this term. So that is minus R into 2R plus 1 by SC. Then this third term plus 0 into the total becomes 0. So now if you solve this, you get this expression. Okay. So this is your delta. Now delta 3. Yes, how to find delta 3? See this third column. This is related to I3. Now this column must be replaced with Yes, the RHS values means the constant values. Okay, so that is, suppose if we want to find I2, then replace the second column with these values. Okay, so now it is K plus 1 into R plus 1 by SC minus R. So what is the value here? Minus HV I. It is RC. RC. Then minus R, 2R plus 1 by SC, and yes, what is here? 0. Then 0 minus R, what is here? 0. Same procedure. This first term into, okay, we have to leave this and this, multiply this with this, so you'll get 0. Fine. Next, minus of minus or, that is plus R of, now leave these two, then multiply this with this, again 0, 0, so it is 0. Then minus HVIBRC of, yes, now leave this and this multiplication minus this, so it is 0, so it will be just R square. So what is totally your delta 3? Is minus HV IB. Yes, in the place of RC, write KR. Okay, already I told you just take RC is equal to KR into R square. So it is minus HV IB KRQ. Okay, then what is your I3? Now I3 is delta 3 by delta. What is delta 3? Minus HV IB KR cube by. So now this is your delta. Write the delta CQ. So totally it will be HV IB KR cube SQ CQ by. For A beta, so A beta is what we got as A beta. See here, A beta is I3 by IB. Yes, this is I3. So if you make I3 by IB, yes, this IB gets cancelled. So you'll be with minus HV KR cube S cube C cube by. Okay, fine. Now just divide the numerator and denominator with R cube S cube C cube. So we'll get minus HFE into K minus KHFE divided by. Here is the term R cube S cube C cube. So if you divide it with R cube S cube C cube, you'll be with 3K plus 1 plus, yes, you'll get here 1 by RSC 4K plus 6. Okay. Then here I'll get 1 by R square S square C square of 5 plus K plus 1 by R cube S cube C cube. Now replace S with J omega. Okay. So I'll get A beta is equal to minus KHFE by (3K plus 1). So if you keep J omega here, 1 by J omega RC. So now multiply it with J and divide it with J. In the denominator, it will be with 2 J's, J into J, J square, it becomes minus. So it will be, so instead of this, it is minus J by omega RC of 4K plus 6. Okay. Then here, S square, yes, what is S square? If S is J omega, S square becomes J square omega square, it will be minus omega square. Then S cube is actually j cube omega cube. In that j cube, you can take j square into j. J square is minus 1. So, it will be minus j omega cube. Okay. So, now what is this term? This term is 1 by minus r square omega square c square of 5 plus k. What is the next term? Yes, s cube is minus j omega cube. Now again multiply and divide with j. So the denominator consists of j square again. J square is minus 1. Already you have this minus. So it becomes plus. So totally it is j by r cube omega cube c cube. Now what I am doing is, yes, I am taking this expression again. Now I'll separate the real and imaginary parts of the denominator. Yes, the real part is 3k plus 1 minus 1 by r square omega square c square of 5 plus k. And the imaginary is, I'll take j common. So I'll get 1 by r cube omega cube c cube minus 4k plus 6 by omega rc. And we know for any oscillator, the conditions to get oscillations are mod a beta is equal to 1 and angle a beta is equal to 0. Okay. So to get angle a beta is equal to 0, yes, imaginary part of a beta must be 0. Any angle phi, it is tan inverse imaginary by real. When you will get 0? When this imaginary is 0. Same way, angle a beta, let be phi. To get 0, imaginary part must be 0. So what is the imaginary part here? This is the imaginary part. So take it as 1 by r cube omega cube c cube minus 4k plus 6 by omega rc is equal to 0. It implies, yes, you can cancel 1 by omega rc in both the terms. R square, so it is 1 by r square omega square c square minus 4k plus 6 by 1 is equal to 0. So it implies 1 by r square c square omega square is equal to 4k plus 6, or 1 by omega square is equal to r square c square into 4k plus 6. So omega square is 1 by r square c square of 4k plus 6. So omega is 1 by, yes, you can take root. So it will be rc into root 6 plus 4k. And we know omega is 2 pi f. So f is 1 by 2 pi rc root 6 plus 4k. Okay, so this is the frequency of oscillations. A bit lengthy but easy. You must note down the total derivation. Okay, just listening is not enough for derivations. Remember, you must practice repeatedly. Now, same time, we have another condition, mod a beta is equal to 1. So now, we derived this frequency, omega. So at the derived frequency, see this expression. What is this expression? This is a beta expression. So at this derived frequency, mod a beta becomes 1. Okay. Mod a beta is 1 when omega is 1 by rc root 6 plus 4k, or when f is equal to 1 by 2 pi rc root 6 plus 4k. So now take this and make it as mod and equate it to 1. So if you take it, the mod minus kh of e by, yes, this imaginary part is already 0. By that only we got the frequency. So it is 0. And then here in the place of omega square, you have to take this omega square. Okay, then we'll write it. 3k plus 1 minus 1 by r square c square into, in the place of 1 by omega square, what do you have to write? You have to write this R square C square of 4k plus 6. Okay. So this mod is equal to 1. Okay, just you solve it. Yes, here you have this 5 plus k. Okay. Yes, this is 3k plus 1. R square C square gets cancelled. So 4k plus 6 into 5 plus k. This is 1. So it implies KHFE by 4k square plus 23k plus 29 is equal to 1. So it implies HFE by, yes, just cancel your k, 4k plus 23 plus 29 by k. HFE is equal to 4k plus 23 plus 29 by k. So this is the general expression to find the value of HFE to get oscillations. There is another term, that is minimum value of HFE to get oscillations. I'll get it by taking DHFE by dk is equal to 0. So what it implies? So if you go for DHFE by dk, you'll get 4, and this is constant. This is by k. So it is 4 minus 29 by k square is equal to 0. So you'll get k is equal to 2.6925. So now at this k, you just calculate this HFE. So you'll get, yes, if you substitute this, you'll get HFE minimum value as 44.54. So what is this HFE minimum? So that is the minimum value of HFE you have to maintain while choosing the transistor. Then only the transistor can produce oscillations. Okay. So this is about frequency of oscillations and the value of HFE required to get the oscillations for RC phase shift oscillator using BJT. Okay. So thank you very much. So in the next video, I'll do the frequency of oscillations of RC phase shift oscillator using FET.